perhaps you're not supposed to be here tonight, or you just don't want to be on social or YouTube, that's all completely fine. Just let myself or Ollie or Adam know, and then we'll just make sure that you're not included in any of the footage. Big thanks to Runway East. So they're actually our venue sponsor tonight. They give us the space for free, which allows these meetups to be free. So just a massive thank you to the venue. They're a co-working space, but they have a mix of fixed office space and then also sort of flexible co-working as well. So if for whatever reason, just really trying to ignore my dog, if for whatever reason you would like a little bit more information or a tour or anything like that, let me know and I can arrange that another time as well. And if we do it through Silicon Brighton, we might be able to give you a little bit of a deal as well. And in terms of Silicon Brighton, so we're the hosts of Brighton and Hove's tech sector. Green Software is one of about 30 tech and digital meetup groups that we support that is happening across the city. So there's a really thriving, vibrant meetup scene that's happening sort of anywhere from kind of 1 to 3 or 4 events every week. They're all free to join, like this evening. People at any levels, all levels are welcome. So you could be in the specific industry or the tech vertical that the group's about. You might not have any knowledge whatsoever. You might be a career switcher. You might just be wanting to get a little bit more information, perhaps for yourself, or you're working with someone and you want to get a bit of a deeper dive and understanding. That's absolutely fine, whatever the intention or whatever level that you're coming into this, that's totally okay. And they're also all hybrid, as I mentioned earlier. But the idea behind all of these principles is that we want the events and then also the industry to be as accessible as possible for people. These are our amazing supporters, so companies who contribute to us financially on a monthly basis to allow us to continue the support that we offer the tech and digital meetup scene to be free. But we need you. We're not completely there yet, both from a company contribution perspective, but also meetup organisers, speakers, volunteers as well. So if for whatever reason you might want to get in some way a little bit more involved with the Silicon Brighton community from an individual basis or with your business, just let me know and we can have a conversation. I can tell you more. These are our values. We, as a team, like to uphold them, but also with all the organisers that we work with, the different groups as well, and the people within the room. So if for whatever reason you maybe feel that you ever come into contact with someone at an event through our online channels or anyone else that doesn't uphold these, again, please have a quiet word with me and we will make sure that that is taken care of. That sounded really threatening, but you know what I mean. In some way or another. You can also follow us on socials. It's amazing to get in the room together, but it's also lovely to catch up online. So we're on all of the usual channels, and we also have a Slack community as well. And that is all from me. I'm going to hand back to Adam to introduce you to tonight's speakers.
So, as I mentioned earlier, so Green Software Brighton is about getting people together to talk about this stuff because the products that we're all building are having an effect on the environment through the hardware that the software runs on. David and James are here from Scott Logic, who are one of the companies in the industry who have a team, sustainable tech team, who are exploring this stuff and trying to understand it. So I think they're going to tell us a little bit more about the role that open source software plays in green software, and also about a standard called the Tech Carbon Standard. So yeah, if I can hand over to one of you guys.
We have a slight problem here. Do you guys no, but I don't know how to switch them off. Sorry guys, bear with me. So I don't know how to use this. So... Go on. Ah, perfect. Thank you. Sorry about that. Can you hear me all right? Excellent. Okay, so this is our open source software sustainability and tech carbon standard talk. My name's James. I'm a lead software developer at Scott Logic, a consultancy. I started my career in IT back in the very late 90s doing technical support for dial-up modems, believe it or not. And kind of went from there to system administration. And then at some point while I was working at BT, reinvented myself as a software developer, which I've been doing for about 16 years. So it's fair to say I've seen Moore's law in action. In childhood, I was using 8-bit computers that measured memory in kilobytes, and now we have cloud computing with an all-you-can-eat buffet of memory and compute and disk space. And isn't it wonderful? So I joined the software sustainability team at Scott Logic, tail end of last year. So I really consider myself to be at the start of my own journey within software sustainability. I'm still learning about this stuff myself, but we wanted to share some of what we've sort of picked up so far with all of you. So far in the project, I've mainly been specializing in looking at how networks behave and software development practices. So that's me. I'm just going to hand over to Dave to introduce that.
Hello, Brighton. Yep, I'm David. I work at Scott Logic with James. UX designer, been designing products for 15 odd years, all kinds of products, digital products, physical products. So I joined sustainability team again fairly recently, October, end of last year. But my focus being on the front end side of things, so user devices, websites, web apps, things like that. But the thing I found since sort of joining this project is there is a myriad of information. There's so much data out there, loads of research, a lot of articles. Unfortunately, a lot of misinformation and confusing stuff, a lot of jargon. So I've been also focused on developing tech carbon standard, which hopes to kind of bring all that together, make sense of it. And I'll talk a bit more about in the later slides. So today we're talking about the sustainable technology landscape on the whole. We're sort of assuming a sort of little knowledge of the area. And we'll talk to you a bit about open source software and sustainability, the effect of open source software development and how it affects sustainability. I'll be talking about tech carbon standard, as I just mentioned, and then we'll look at the tech carbon standard with a lens of open source software and how that kind of fits into all of that. So I'll pass back on to James.
So, bit of audience participation. Where are you all on your own sustainability journeys? I mean, quick show of hands. Does anyone here have reusable water bottles or coffee cups that you take to coffee shops or anything like that? Cool. Smart meters in your home? Yeah, quite a few. Okay, does anybody leave appliances on 24/7 at home? Ovens, for example, at a constant temperature so that you don't need to preheat it. Absolute convenience to be able to just cook your food straight away. No? It'd be madness, right? But we do it in IT all the time. We've got environments that we use only during the day and then leave running all night. We've got, I can't remember the percentage off the top of my head, but there's a whole percentage of cloud computing that's just zombie VMs that just sit there running. People spun them up to try something out, did their little experiment, just leave them running and never go back to them. And we like to think of cloud computing as being this infinite, ever-expanding space, because that's kind of the vision we're sold a little bit, right? But in reality, those are just data centers, the same as the ones we've already always had. And the more pressure we put on them, the more data centers they've got to create. So, you know, that there is an impact to those zombie VMs just sat there running. So when we think about technology and sustainability, there are two sides to the coin, right? You've got the digital side on the left here. And here we're talking about the energy that's being used as we use the devices. So, but we have a tendency to ignore the physical side of it. The fact that if you've got a phone or a laptop, a lot of the energy that was expended in its creation, from mining the materials through to assembling it in a factory and delivering it to your door, all expended energy, and all of that we refer to as embodied carbon. Now, if you look at a mobile phone, about 80% of its emissions across its life cycle are actually in its embodied carbon. About 20% in its actual running costs, which makes sense, right? They're fairly low power devices. They've got batteries, makes sense. If you look at a server, you kind of can flip that around a little bit, again, on average, you're looking about 20% in its embodied carbon and 80% in its running costs. It's running 24/7. It's sucking up a fair amount of energy. It's being cooled constantly, things like that. Now, has anyone come across the sustainability goals for the UN, right? So these, for those who aren't familiar, these are a set of goals that the United Nations put together to allow governments, institutions, charities, businesses, whoever, to align their project with a sustainable future for our planet. An example of this in Wales, where I live, they recently started coming up, well, I say recently, I think they've been running it out for about 10 years, but they've come up with a new school curriculum. And when they were doing that, one of the things that the school my son goes to actually did was they checked how their curriculum lined up against these goals to make sure that our children had the tools in the future to create the sustainable world that they want to live in. Similarly, at Scott Logic, we went through an exercise to see how these goals map with environmental impacts. So again, this kind of mirrors the slide we had a few moments ago, but as we start on the left, you've got your energy consumption, the place where we tend to instantly go when we talk about saving energy and reducing carbon emissions. And we want those to come from clean sources where possible. We don't want to drive the use of more coal and gas and other fossil fuels. And of course, climate action comes in the form of land use, for example, data centers and factories to make laptops and phones using up land. And of course, we also get carbon offsetting in that category, where some companies will start planting lots of trees to try and offset their sins elsewhere. But of course, if we've just cleared out a meadow, for example, in order to build a new data center, we've affected a bunch of habitats, so we've affected life on land. We want to try and keep our industrial infrastructure as sustainable as we can to reduce its impact. But the place I really want to draw your attention to is on the far right, the responsible consumption and production. So there's a trend in technology to keep pushing the boundaries, to keep selling you the latest, greatest gadgets. Phone companies especially love to sell us a new phone every 2 or 3 years. And we have a place in this by creating software which requires higher and higher specs, that uses more memory, that uses more networks. We are driving that demand. And one of the ways that we can actually take the pressure off a little bit is to make sure that our software runs with lower memory consumption, makes less network calls, consumes more backwards compatible with older operating systems, so that we can allow people who've already expended that embodied carbon I was talking about to buy their phone or their laptop and let them keep it for another year or two. The numbers get better the longer that device lives for in any useful way. And the last two there at the bottom, I just want to kind of give a quick shout out to life below the waterline and clean drinkable water and sanitation. They're impacted as well, because as you start mining materials, like things like lithium for batteries, that creates a lot of runoff, which affects life in the seas. And of course, our data centers all need cooling. There's a lot of water being taken out of the system that we've got to think about how it kind of goes back in. These are all impacts that we need to be cognizant of. But these goals don't live in isolation to each other. They're not separate little islands. And as you start looking at this, you see this sort of Venn diagram. And yeah, we start off with becoming carbon aware and trying to be greener, but we actually find that there are crossovers. There are multiple wins to be had when we start looking at security, the skills we've got, at managing our own technical debt in our products. And as we start doing all those things I've just been talking about and lowering the overall requirements of our software, we actually make it more economically viable. If we choose the right battles, if we apply our effort in the correct places, we can actually make it, manage the total cost of ownership of our software. which makes it easier to sell to our stakeholders. So, as luck would have it, I've actually got a slide all about the Green Software Foundation and the software principles that they kind of came up with. And these are really great sort of guiding stones for anyone who's doing any software development in this space. So we start off talking about energy efficiency. What we're looking to do here is make our software as efficient as we can, by lowering the CPU usage, lowering the memory usage, and whatnot. Hardware efficiency, as the name suggests, is about being more aware of the hardware we're using, trying to reduce the amount of hardware that we're consuming. If we're in the cloud, perhaps using smaller VMs, less VMs, or cloud appliances, whatever you want to call them. And carbon awareness speaks to being aware of where the energy is coming from. So you might be running, as an example, if your software is running in Scotland, Scotland has a lot of green energy in their grid. So a lot of renewables, hydroelectric and the like. Chances are, if your software is running in there, not necessarily, but there's a chance that you've got to look at it for yourself. But there's a chance it will be running on cleaner energy than, say, something closer to London, which might be running off gas or coal or whatnot. So let's just take an example here. Let's say you've got a CMS running on something like a LAMP stack. Doesn't have to be, but chances are in there you've got a web server of some description. That web server also has some kind of interpreter built into it to deal with the dynamic content, and you've almost certainly got a database of some description backing it up, like MariaDB or some such. Now, you've got to look at your actual usage. So this would be a personal thing, but for the sake of argument, let's say you looked at it and you found out that actually the CMS was only put in as a convenience to the marketing people who aren't as IT literate as the developers, and they update it once a month. A lot of that is waste, right? They're not actually utilizing the CMS in a fashion that that really justifies the carbon cost of it. So you could replace it with a templating system that just compiles a static website, something like Jekyll. If anyone's used GitHub Pages, that's exactly what it does. Right, so now we've just gone from having a web server with an interpreter built in that's actually actively interpreting that stuff to having a simple web server that just serves a static HTML page or set of them. We've lost the DB completely. So we've already lost all the processing we have to do around PHP or whatever language you're using. We've just lost one of our servers. The server we have got left, or cluster we've got left, we can probably downgrade a little bit. Or put something else on there that it didn't have the space for before. And theoretically, and I caveat this one heavily, if we imagine for a second that we've just, a lot of the time with cloud computing, it kind of sinks its hooks in. You get kind of trapped in this golden cage. And people talk about being able to use multiple clouds, but practically speaking, it's next to impossible. But if you just simplified your system to the point where it's just a set of web pages, actually, that's just a build script, right? So now, if we found out that cloud provider A is more energy efficient than cloud provider B, it's just a script to flip it over there. And let's say cloud provider B gets its act together and suddenly starts becoming a lot better than A, we can flick it back. And that's not the best bit. The best bit is that we've also reduced our attack surface on our software because we don't have an admin page for the CMS anymore. We don't have any possible vulnerabilities that are built into the CMS itself or into the programming language that it's built on. And we've also lost the database. We've reduced the hardware attack surface because we've now got less ports open. We've potentially got less servers. We haven't got a database server at all. And let's say in our theoretical, we were able to move around the cloud. One of our cloud providers had a massive outage or a huge security vulnerability. We've got all the scripts we need to flick over to a different one. And we've also probably lowered the cost of everything as well at the same time. So this is a triple win. Admittedly, contrived example. Your mileage may vary depending on your application, but these are the kinds of synergies that we're looking for where possible. But doesn't that mean you can just summarize the entire talk so far to, should we just design and code better software? Yes, but where? What software should we be optimizing? So if we look at the software in your organizations, chances are you're effectively in a pond and you can make a ripple there. Yeah, just looking at software alone, not worrying about hardware or the bigger picture within that organization, just looking at software optimization. There are a few exceptions to this. Maybe you've got a global brand that has millions of users. Perhaps you run a manufacturing process. Yeah, totally be looking at your stuff. You can make a huge impact. But a lot of us don't work for organizations that large. And so the impact we can have with software optimization alone is limited. Not worthless, but limited. But if we start looking at our dependencies and start looking at open source software, we have an opportunity to turn that ripple into a wave. Because now, when you save just a single milliwatt on that piece of software running, you're not only hitting that bit of software and your own organization, you're hitting every other organization that uses it as a dependency. So when you're looking at, for example, Express.js that's used in Node, that's its dependency tree. If you can find a place in there to make a difference, everyone who uses Express gets that benefit. And now you're looking at a huge impact for this, potentially the same amount of effort. But as I say, we can only get so far with software optimization. Really speaking, especially, and I'm focusing back on our own organizations now, we need to look at the wider technical landscape and look beyond code. Think about being open with your data. If you've taken the trouble to find out what the carbon footprint of running your software is, share it. Let the people who consume your software know what that is so they can make adjustments around how they consume that software. Be transparent about it. Be willing to be, challenged on how you've done it. By being transparent, it prevents things like greenwashing, which is a temptation that any company might get into with the best of intentions. And there's other parts to it as well, like finding all this data, and David will talk about in a moment, can be really, really difficult. I mean, just trying to find out what was the embodied carbon in the router that you use in your building, or how much power does it suck up? What about the servers that you're running? Some organizations are easier to get to. There's some good tooling around cloud platforms, but there's also some opacity there. But the more data we can kind of share, the better it gets for everybody. AI as an example, I've got a funny feeling you said you did a talk on this recently, Ollie. How much energy does it take to train an artificial intelligence machine learning model? How much does it then, once that's actually done, how much does each call to it cost? That's data that we all need. So at this point, I'm going to shut up and hand over to Dave so he can tell you a bit about the Tech Carbon Standard, which will hopefully help organize all this.
Thank you. Hello again. So as I said at the beginning of the talk, when I started the journey, there's just this huge amount of information out there. And this is just literally a snapshot of a small handful of brands and logos out there. I'm sure you recognize a few. I hope so. So when I dived into this, I was just sort of bombarded with all this information, was research, was data, always places to go and find information. And a lot of it is great. Some of it's crap. Unfortunately, that's the reality of it. But these are the good ones, mostly. No, they're all good. Just a couple of point outs. Green Web Foundation, if you're not aware of them, they have a CO2.js library, which is fantastic. It's used by a lot of website carbon calculators. You can basically provide the amount of data that's passed through to a website or a web app. You can also pass through the location, and it will basically give you back an emissions sort of estimate. They also maintain databases on green web hosting companies. So if you're looking for green web hosting, they've got data sets that actually kind of verify and confirm what is green, not just what the provider says. They will actually verify it. We've got cloud carbon footprint. So if you have a large sort of cloud infrastructure, it's interesting tools, all open source as well. It has an interesting sort of way of measuring it. It looks at your billing and your usage, and basically from that it works out roughly, again, a carbon estimate. And finally, you've probably heard of them, Green Software Foundation. They have an online course. If you haven't done it already, please do it. It's amazing. The Green Software Principles. It explains a lot of great stuff. A lot of jargon is kind of clarified, and there's a little exam at the end. Takes a couple of hours, but it's fantastic. Highly, highly recommended. Okay, so what are we doing at Scott Logic? Well, as I said, we're trying to kind of make sense of all this data, all this information, all this research, and trying to bring it together and kind of create some sort of navigation around it all. So a month ago, 6 weeks ago, we introduced the Tech Carbon Standard, techcarbonstandard.org. It's still being fleshed out. There's still things we are doing, but there's generally a lot of information that we've collated from other sources, things that we think are true and the right, and just kind of bringing together all the right things and signposting to the good stuff. It is a proposed standard. I mean, how do you make a standard a standard? But the idea is to create a kind of classification, taxonomy, and structure to organize your estate. Your entire technology estate is complex. How do you organize it? How do you report on it? How do you identify the pieces? So that's what it's all about. It's kind of just trying to make sense of it all, as well as sort of explain and signpost to good methodology, ways of mapping this, etc. Like I said, there's information about methodologies and ideas about how to measure. There's a whole glossary page we've been developing, which kind of just hopefully cuts through the jargon a little bit, makes it a little bit easier to understand. But I want to talk to you about the main infographic, which you'll see on the website. By the way, this is a sneak peek. We haven't actually released this version yet, so you're very lucky to see a preview. There's just a few tweaks to wording and an extra item in there. You can spot the difference later. So there's three main categories: upstream, operational, and downstream. It's fairly, hopefully, self-explanatory. But the upstream, category U for upstream, little number next to it is to do with the GHG protocol. So if you're aware of GHG protocol, it's kind of relating back to that. So category U is all about your upstream embodied emissions. So if you're buying in hardware or even software, those things have embodied carbon. So the production, manufacturing, distribution, end of life, all of that has some carbon associated to it. Same as software. People forget that software has embodied carbon because it took time, energy to produce and distribute. So software itself has its own carbon footprint. Easy one to forget. And when you acquire these hardwares or softwares, that embodied carbon is a constant. So regardless of how long you use it for, it has X amount of carbon. The longer you can use it for, obviously, the better that works out. And if you're replacing a laptop with 400 kilograms of CO2 in it, if you're replacing it every year, that's 400 kilograms of CO2 per year. You spread that over 4 years, that drops down quite considerably. Next step is operational emissions. So we've broken this into two pieces. There's the direct and indirect. So category O for direct, on-prem. This is the direct energy you are using to power your devices. So that could be laptops, desktops, monitors, the equipment you're using every day to do your job. We also have networking infrastructure. So your building infrastructure network is included in that. And of course, your on-prem servers and storage. All these things you are paying directly, maybe not you, but your business is paying directly the energy bill for that thing. And ultimately, you have control over switching that thing on or off and managing it. There's a little subcategory, category G for generators. So if you have backup generators or you need to use generators, that in itself, depending on how you're powering it, is just categorized under direct. It's just we're just capturing that as well. It's one of those little edge cases. Category C for cloud. So this is all the stuff you are paying for. You're paying a provider to provide a service, whether that's a cloud service or a SaaS or a managed service. You aren't directly paying the energy bill, but you are paying somebody else to provide that service. It's up to them to pay the energy bill and be efficient. So that is an indirect operation cost. But in total, whatever it is your organization is doing, whatever it is you're producing, whatever kind of product or software you're producing, this is the usage to produce that product. And finally, downstream, category D, downstream. This is all the usage to do with that product that you are putting out there for people to use. So that could be B2C, B2B, it could be a simple website, it could be an e-commerce site, it could be an application. The energy used by that software on their device is a downstream emission. So you can have a pretty big impact on that. If you make your software efficient, they'll use less energy on their device as a positive. We've also got network data transfer. So this is the transmission of that data to a device and all the network traffic between the two. Again, this has an impact on just the infrastructure around the world, the internet. Again, you can reduce the amount of the payloads you're sending around the world. You can kind of reduce the energy costs again and the emissions. Finally, downstream infrastructure. This is a new one that it's not on the website at the moment. So this captures all the other stuff. So servers, so end user servers and IoT devices, et cetera. All those things you may not be an end user directly interacting with it, but at the end of the day, the software and the products you output will have an impact on those devices as well. Just to mention, out of scope, we've got people, buildings, and travel. So as an organization, if you're reporting your carbon, you would capture those things. But the TCS is specifically about tech. And this is where we identified a gap. There's very little information out there, especially around GHG protocols, about how to organize and map and get the taxonomy and structure all of this. So despite it looking very simple, this was a few months of work. Went from very complex diagrams to finally something that's understandable and easy to use. So we spent last week having a look at TCS, but with an example of Express. So Express.js, we wanted to see what that would look like in terms of mapping and structuring that on the TCS. So on the upstream, first of all, software. I've highlighted the ones that are probably the most significant. There are probably other edge cases, but we're just kind of pointing out the big ones. So software, as James said earlier, we have the dependencies. So Node itself, if you were to contribute to Node and you made that more efficient, it would have the upstream effect of making Express more efficient and reduce the emissions there. In terms of hardware, again, upstream hardware, as a collaborator, we're contributing to Express, your device is a part of that. So again, if Express was particularly hungry and required the latest processors and power, and if you wanted to work in Express, you need the latest machine, you need to buy a new laptop, it's additional emissions that are really unnecessary. So operations. So if you are contributing and working on Express and you're contributing to the code, your device that you are using and the amount of time you spend using that device is using energy, is emitting carbon, that is accounted for on that software. And in terms of the indirect stuff, if you are running a test environment or a dev environment and you're testing Express on a cloud server somewhere, that's an indirect cost. So again, you're not paying an electricity bill, but someone else is. So if you're spinning up dozens of test environments, that's all additional energy being used. So you can be a bit more efficient, just use what you need. I think that's the key line. And SaaS. So again, you're doing an Express contribution, you're probably using GitHub to host your repo, distribute it, share it. GitHub is a SaaS product in the day, and again, that is using energy. and NPM as well. And of course, Express and NPM, they have their own websites. Those websites are hosted somewhere. They are using energy. So again, key thing is, if you're using these things, they are using energy, they are operational emissions, and they are actually contributing to the cost of Express. Finally, we have a downstream. So Express is a product. It is a software product at the end of the day. If you were to make Express run more efficiently on a machine, use less energy, use less processing, you can reduce what might be milliwatts or fractions of a milliwatt, but that long, the reach across the world and millions of people using Express, you can reduce the energy quite considerably. Even if it seems like a small bit, it all adds up. So your Express server could be affecting network data transfer. You can make sure that the network you're passing to and from your requests are as small as possible, as little as possible. And then, of course, Express running on a server somewhere downstream. Again, you can reduce the amount of power it's requiring and make it more efficient. Like I said, it's probably tiny little milliwatts of difference, but when you spread it over millions of users, it's a big impact. James, did I miss anything technically?
I don't think so. I just wanted to clarify the one we're talking about upstream emissions and user. Apologies. I just wanted to clarify that when we're talking about upstream hardware emissions, we're talking about the contributors to the upstream, it's the opposite of dependencies, requirements. So like, for example, the people who contribute to Node.js itself, it would be their hardware we're looking at there. And the user devices for operational emissions would be the people who are contributing to Express. One of the things we realized when we were kind of looking at this over the last week or two was that very few people think about the embodied carbon in open source software because it's bloody difficult to measure. But yeah, that was it.
Thank you. Okay, so what can you do about it? Well, as we're discussing, open source software has a huge reach. Potentially, all those dependency, the whole dependency chain, all the things that it can affect is potentially huge. So a small efficiency change goes a very long way, potentially. Consider your downstream. So yeah, make things more efficient, make them run on older devices, make those devices last a bit longer, push less demand on the networks and the systems out there. If you keep pushing for more and more things, then more and more data centers are going to get built. Simple as that. Obvious things: shut down unnecessary dev or testing instances. If you're not using it, shut it down. Just reduce the load. It all helps. And finally, this is kind of a minor one, but again, just removing repositories, your forks, branches, things like that. It's probably not much data, but it's still data somewhere. Reducing it, every little helps. It all goes a long way. So I think that's pretty much it. So Tech Carbon Standard is open source. We welcome all kinds of contributions and help and ideas. By all means, throw stones at it. Tell us we've missed something or it's complete rubbish. We want to make it the right thing. So by all means, please get in touch. Yeah. Well, finally, thanks for having us. Really appreciated being here. So yeah, thank you, everyone.
Yeah, I just want to say thanks again to James and David for coming along. Excuse me. They've come all the way from Wales, so I think we should all buy them a drink at the pub later. Send them home very merry. So we've got a few minutes now for questions, if anyone has any questions for them. And we have... Yes, we have another microphone here as well. So just put your hand up if you... here we go, in the back there. Oh.
Hello.
Hey, there we go.
Awesome. Nice work on the Tech Carbon Standard. It's really cool. Where would you say the biggest challenges of sort of measuring across there are? Like, obviously some of them are easier than others, but where's kind of like going to be the hardest way to measure the impact?
Right. In my experience so far, it's within the software itself, it's really hard to narrow down exactly what's expending energy on a server. So I talked a lot about trying to get it to use less CPU, but actually trying to work out what the carbon cost of any given program is pretty difficult, because like, how do you measure it? If you put a monitor on the plug on the server, that'll give you an overall thing, but what else is running on that server? What else has Microsoft chucked on there, or whatever Linux distro you've got that's phoning home, or what have you. So it's really hard to isolate those particular bits. What's some of the other things we've had trouble with?
Let's say indirect stuff generally. If it's indirect stuff, servers, because you don't physically have any kind of control over it. You can't physically see it. You don't actually necessarily know what the device is. You just can't measure it. And I think Cloud Carbon Footprints is trying to bridge that gap by using billing and usage, but there's a lot of problems with trying to figure that out, because how much you pay is not the same as everyone else is paying. So all the indirect stuff, definitely difficult.
Sorry, just to add to that slightly, there is another problem that comes with measuring, and that's around how you attribute carbon versus how its consequential usage. What are the effects of altering it? Because they're not necessarily positive when you start looking outside of your own system. There was an example you found, wasn't there, about a company, was it a whiskey company, that decided to start reusing something, one of the byproducts in their manufacturing process, which of course made their carbon footprint go down. But prior to that, farmers had used it. And so as soon as they stopped sharing that byproduct that previously they hadn't needed and the farmers used, the farmers all had to go and buy something to replace what they'd now just taken. So while their carbon footprint had gone down, all the farmers in the area had gone up. That's what we talk about consequential. When we talk about attributional, you get a lot of statistics around networks, for example, about how if you take the amount of data it is and multiply it by some factor, like, I don't know, 0.06 is one of the numbers I see doing the rounds, then your data costs X amount of carbon, which, is debatable. But the point is that that's a really good measure for working out who's responsible to be looking at it, but it's a really rubbish measure for working out what your actual carbon output is, because it's not precise enough. It's just a proxy to give you an idea of where to go looking. So that's the other side of that coin.
Any other questions? Yeah.
Sorry. Of like the three kind of big like cloud services like Google, Azure, and AWS, which one would you recommend? Like green wise?
I'm not sure that we can actually recommend any one. It very much depends. No, nothing to do with we've got no affiliation with any of them, but I think I don't think there's a silver bullet answer to any of these kinds of questions. You've got to look at your usage and where you're using it. So it could be that I think we had a use case pretty recently where someone was looking at their on-prem servers and moving them into the cloud, which on paper, and especially if you listen to the cloud providers, it is the accepted wisdom. But we kind of realized the cloud they were moving to was in London and they were moving from Scotland. That's why I mentioned that earlier in the talk. Chances are they were going to increase their carbon footprint going into the cloud in that specific use case. Does that apply to everyone? Certainly not. So you've kind of got to look at, first of all, you've got to look at your organization and start categorizing where you're emitting carbon, where it's embodied. And then you've got to start asking hard questions about it and make decisions based on whatever data you can get hold of. So if you can get, there was a slide earlier on which there's a tool, a cloud carbon footprint tool, which will give you some data on the various clouds, and you can look at it for your specific use case. But sometimes it's a matter of going in and trying to get data sheets on whatever hardware you've got on premises, to see what that's using. Basically, it's not easy. It takes effort, which is a pity, but it's where we are.
I'll just add on to that, not as a recommendation, but of the three that you mentioned, there's it's hard to compare which one is going to be more energy efficient, but you can compare the tooling that they have available. And when we last did a bunch of research, which is quite a few months ago now, at the time, Google had what we thought was the best method, and they had a whole methodology around how they computed the numbers, and that it was location based rather than market based, meaning that you can kind of offset based on power purchase agreements and things. So that might be one differentiator that people might want to look at. That's a recommendation.
Location based is definitely one of the key things. So rather than which provider it is where is the data center, and the green energy, the carbon intensity of the energy provided to it. That's the key thing. But also you need to consider where are the users using that data center. If your customers are all in the UK, there's no point having a server in the US because you've got that carbon intensity of transmitting data. But it depends. There's a lot of things to depend on. Also worth mentioning, not to shame AWS, but AWS have a 3-month delay in reporting their carbon. So if you're looking to kind of make changes and actually look at the difference you're making, you're going to have to wait 3 months to see our data in their own tooling. It's rubbish. We don't know why. It's just what they do. And finally, I don't know about all of the providers, but I know, again, shaming AWS, they're aiming for obviously carbon neutral. So eventually, when you ask for, what's my emissions, it's going to be 0. But it's not true because they're carbon offsetting. So you think you're getting 0, but it's not 0. It can't be. They're just offsetting it. And so I believe all their data is market-based. So yeah, bear that in mind.
I think they also, just to back up AWS, I think they just bought a nuclear-powered warehouse.
Yes, they did. Yeah. Which arguably is low carbon nuclear power, but
any.
Mark had a question out front there.
Yeah, hello. With the open source stuff, I was just wondering, would you have any recommendation of where you could get started? Like, is anyone compiling a list of the big hitters that would make a massive impact, or where would you go to start trying to help with that kind of thing?
No idea. Pick one. Obviously, the bigger reach it has, the more dependencies it's being dependent on. It's obviously going to have a bigger impact. But I actually don't know.
They definitely will.
Although, if I'm honest, I would start looking. If it was me, I would start looking at my own skills and see where I can contribute. Because arguably almost any open source project will be glad to have you. And obviously, the really big hitters are the ones where you can get the most reach as far as carbon efficiency is concerned. But who's to say that the project you choose won't become a big hitter with your help? So I wouldn't limit it just to like Apache and Node and Express.
So one of the event ideas that we've had with Green Software Brighton is to run a kind of hackathon type thing, where we pick an open source or group of open source projects and try to do something practical, try to actually make a difference using some of the tooling that's available. And just rolling up our sleeves and trying to reduce the carbon footprint of some open source projects. So if anyone is interested in coming to an event like that, let us know, and we'll start the immense amount of work that will be required to organize, probably with the help of Fiona over in the corner there. But yeah, are there any other questions? Unless anyone wants to add more to that. Okay, no. So any other questions? I have one, and that is, how do you go from the wonderful, beautiful pictures that you've got of the what's it called, the tech carbon standard, and turn that into an actual standard that can be used in industry? Are there any plans, or do you have any idea how you actually do that? I imagine going to a body like IEEE or W3C or something like that.
Yeah, that's the I guess the $1 million question. Yeah, how does a standard become a standard? I guess the main thing is the industry has to embrace it. The more people that get behind it and embrace it and start using it, the more tooling that kind of starts relying on it and using it. I probably shouldn't name names, but we are working with someone to actually start implementing it into their system. No, I'm not going to say it. It will be open source. It's all going to be announced some point, but yeah, it's all an open source project. There's no secrets behind it really, but it's only just sort of being agreed. But yeah, we're just trying to get more endorsement, more people using it, more people get behind it. But it relies on people throwing stones at it. We need people to say, you missed that, that's wrong, we don't agree, throw more data at it. Actually, it needs to be backed. That's why it's open source. We need people to back it, get behind it, and kind of make it right, basically. Hopefully, it's just adoption. And then once we've got that adoption, we can go to GHG and get GHG to get behind it. So yeah, it's just get that ball rolling first, I think.
Sorry. Just wanted to add to that. It is released under a Creative Commons license as well. I think it's a Creative Commons non-commercial license. So, if anyone here does decide to take a look and hopefully contribute, it is open source. It will remain open source. This is the bit of the system that we want to share with people. So, and I think that speaks to that a little bit, of how to kind of get it accepted as a standard by making it open for people to extend.
Well, that leads somewhat into the bit that I want to leave us with, which is just a little bit of a shout out, a little bit of a bit of good news, I guess. For those of you who don't know, Adam and I set up a software consultancy, green software consultancy called Root and Branch back in January, and we've received some funding to develop a kind of green metric tool, a tool that will allow software developers to gain some insight into the carbon emissions and the power consumption that their software is emitting. Its working title is the Cardamom, which stands for the Carbon Dashboard and Live Monitor. We're due to start in April, aren't we? Mid-April.
I'm glad you know.
Yeah, yeah, thanks. Yeah, and actually, it would be wonderful to talk to you guys about maybe, shoehorning some of this into the tech carbon standard. Yeah, so it was just this tool is an open source project, so anyone is free to go and raise pull requests and get involved and help us build this tool. And yeah, I just wanted to put it out there. You can find the GitHub on the URL on the screen. This is very much a proof of concept at the moment. This is a dirty GitHub repository, and there's going to be a flurry of activity on it in the coming months. And I think now it's the time to go to the pub. Should we go to the pub?
Yeah, I just wanted to add one thing on the end of that, is that one of the biggest challenges that the industry has is measurement. This is just one project. There's a whole bunch of other projects. And in April the 30th, Asim, who's the director of Green Software Foundation, is coming to talk about a project that they have that's tackling measurement as well. So yeah, definitely come to that, because that's a great opportunity. He happens to just live up the road, so we're quite lucky that he's coming to talk about that. That's it.
Yeah, we've definitely lucked out. This is definitely a good part of the world to be in for green software. The pub we're going to is the World's End. I hope people know where that is. There's some nods. But it's just around the corner there, and I think you can actually get to it going this way as well by going down some stairs down, and it's around the back here. We'll pack up here and we'll head straight over, I think. So thank you all for coming. Oh, and I should just say the next event is on the April the
30th.
30th. There we go. Isn't that amazing? Two people that know the date and I don't. It's on April the 30th, yeah, and it's with, so, okay, wonderful. See you later.